Okay, in this video I'm going to talk about binary operator overloading. You have a couple of binary operators that you can overload, and we are going to start with the arithmetic operators. We have to remember that we are going to use infix notation, and this is going to be declared as a member function. So in the declaration you can see we have the return type. I've done some highlighting here, so operator, the symbol, and then as a parameter it's going to take a reference to a constant user-defined type. So the formal parameter name here is other. That can also be RHS for right hand side, because let's say you have entity 1 plus entity 2. The function will actually be invoked on entity 1, so the one on the left hand side, and is then going to take in entity 2, so the one on the right hand side, as an argument. Okay, so I'm going to move on here. That's just a summary for you on what the declaration and definition headers will sort of look like. Again, you have to take into consideration that in some cases where we overload that operator, it's not going to modify the calling object. Okay, so as we've seen in previous videos, in those instances you want to qualify those functions as const. Okay, so here are the redefinable binary arithmetic operators. You have addition, subtraction, multiplication, division, and modulus. Now, of course, these are not the only redefinable binary operators. We are focusing for right now on arithmetic. In upcoming videos, I'll talk about comparison, for example, and some of the other binary operators. For this example, I'm going to use the entity class again. In the public section, I have a constructor. It has a default argument. I set member p to 5, and I'm going to use that to initialize the member. I also have this helper function to string, which is const qualified, and that's simply going to print out the member to the console. I have a single member here, an integer in the private section. So I'm going to do addition. The other ones you can sort of try by yourself, multiplication, subtraction, and so on. Those will be very similar. But before I overload the operator, I'm going to define a function. Okay, so with this member function, the idea is to call this function on the object and then pass in as an argument another instance of the entity class. To add these together, we are going to add it in a temporary variable, and then we are going to return that. Okay, so this is what the function will look like. I can do temp.member to access the member variable of that temporary object. Member right here is the member of the calling object, and then we can do other.member. So the parameter again is a reference to an entity constant. We don't want to change in the argument or the object that we pass in. We simply want to add the value that its member stores and the calling object member together and then return that. Now if you think about this for a second, this member here is private. So you might be thinking, well, how can we do this? So this other.member, that member is not part of the calling object. That is what we have right here. So how can we do other.member? Because again, that member is private. And the same thing here, actually we have entity temp, and then we do temp.member. And I want to emphasize this here before I move on. So before we move on with this example, I'm going to bring up a slide where I summarize this for you, and then when we come back, we'll continue with this example. Okay, so we talked about member access modifiers before. These allow the programmer to specify access rights for the class members, and it relates to the concept of data hiding. Public members are accessible using the dot or arrow operator, depending on whether it's a pointer or not, right? Members in the private section are accessible by member functions of the same user-defined type. Now when I talk about user-defined type, again I'm talking about our classes and our structs. Now note here, member functions can access the private members of any accessible instance of the same user-defined type, not just for the calling object, or in other words for this. Formal parameters are often of the same user-defined type as the calling object, and this is very useful for operator overloading, copy constructors, and the assignment operator if you overload those, because we don't necessarily want to provide getters for every private member. Again, this also revolves around the principle of least privilege. You should only provide what you really need to provide. So the point with this is you have access to the private members in member functions of the same user-defined type. That's not on a per instance basis. Or in other words, it's not just for the calling object, it relates to the user-defined type itself. Okay, so before moving on, let's test if this function works. In main, I have these entities set up already, entity 1, entity 2, and result. Okay, all I'm going to do is a result, which again is an instance of entity. I'm going to do entity1.add, and I'm going to pass in entity2. that should assign 10 to the member of result. So it's going to do what is known as a member-wise assignment. So every member from that temporary object that this will return will get assigned here. So if you had 10, okay, so member 1, member 2, and so on, it's going to assign every one of those to the identical members of this result object on the left here. Okay, for right now, I'm just going to build and run, see if this works. Okay, it prints out 10. We'll talk about overloading the assignment operator in future videos. That's going to be important for when you have pointers as members. But for right now, this works fine. Now, of course, if it's a struct and you want to be explicit, then you can do result.member is equal to this, okay? Instead of using the default value, I'm just going to make this a bit more clear. I'm going to use the constructor. Okay, so initialize the member of entity 1 to 3 and the member of entity 2 to 12. So this here should print out 15 now. Okay, and that is what we get. I'm going to scroll up and do one more thing. So we create this temporary variable and then we do this stuff and then we return that. But to keep it concise, and since we have a constructor right here, what you can do is just going to remove that. And we can construct the entity right here. Okay, so what are we going to pass in as an argument? That constructor takes in an integer. Well, we do. Okay, so you can do this, return entity. That's going to create an entity and it's going to return that temporary object back to the calling function. This is quite concise and it reads quite easily as well if you are used to this sort of thing. I'm going to leave that as is and pull and run, and that works fine. Okay, but imagine you have something like this now where you have an add, so you want to do addition, you want to do subtraction or division, multiplication. It can become difficult to read, especially if you want to do a bunch of operations in one statement. So instead what you can do is you can overload the addition operator. And then you can do the exact same thing. So if you look closely, you'll see that the add member function and this overloaded addition operator, those do not modify the calling object in the body or in the definition. I'll qualify those as const. Okay, so we can use infix notation with this plus operator now, this addition operator, instead of doing the member accessor and then specifying some function that we want to call. And of course, once you start chaining these things together, it becomes easier to read. Scrolling down, this is what I can do now. Result is entity 1 plus entity 2. Okay, that's going to return a temporary object. The member of that temporary object is going to be initialized to 15 in this case. And then we have a default assignment operator for our user-defined types. And it's going to do member-wise initialization to assign that member or the value in that member to the member of this result object. Then we simply do result.toString, and that works fine. Okay, so this is easier to read, and that is thanks to that infix notation. Just a few more notes for you. Since we have these functions now, add and the overloaded addition operator, we can use them in each other's definitions. So for example, we have add. What we can do in here is something like this. You can do add other, and that's going to call this function. And then of course we pass in this here into the other section. Okay, we still have the statement right here to add those up. Let's just build and run to see if this works. That works fine. Alright, I'll just undo that. Then I'll go back to the add function. Then I can do this sort of statement. I dereference this. I use this overloaded operator, the overloaded addition operator. And then on the right hand side we have other. We do entity1.add entity2. That'll give us 15. You don't want to do both of these at the same time because that will lead to recursion. For example, in the add function, we use the overloaded addition operator. And if you call the add function here instead of doing this, then it's going to go to the add function. And in the add function, it's going to go to that function again. Okay, so you want to try and avoid that. And one final example here in the add function. Remember that these are basically like functions. Again, if I scroll down, Here you can do add, or you can do entity 2 like that. Okay, I'll just undo that. Just a few bonus notes for you. I'm not assuming at this point that you are still very comfortable with this stuff. That is why I'm showing this to you. I could make much shorter and much faster videos, but I prefer to sort of highlight these different topics to you. Okay, so what I'd like you to try and do is go and overload the multiplication operator. That should be very similar to what we've done here. So I'm going to go and do that, and when we come back I'll show you my implementation and also recap why it's more readable to use these overloaded operators and infix notation as opposed to using regular member functions for everything. Okay, so go and try the multiplication operator by yourself. Okay, I'm back. I'm in the entity class again. We have the constructor, the add function, the overloaded addition operator, and here I have two more functions, the multiply function, and then I've also overloaded the multiplication operator. So you can see it's very similar. The parameter is basically the same, a reference to a constant entity. It's going to return an entity. Okay, I do member, so the calling object's member. I multiply that with other.member. These functions are also qualified as const because they do not modify the calling object. Okay, and the operator basically has the same statement, return statement. In main I have entity 1, I pass in 3 for the constructor, and entity 2 I also pass in 3 for the constructor. Here I use the multiply function, so I do entity 1 dot multiply entity 2. That will give us 9. Or I can use the multiplication operator with infix notation, pull and run, and that will work fine as well. We get 9. Okay, so let's do something else. If you can think for a second which one is easier to read here, we do entity 1 dot add, then we do entity 2 dot multiply entity 1. Okay, that is a lot compared to this statement right here, where we simply do entity 1, the addition operator, entity 2, the multiplication operator, and then entity 1 again. We will still have operator precedence, so what we can do is, I'll comment this line out, and then I'll build and run this. We get 12. Okay, it's going to multiply this stuff first, so it's going to be 9 plus 3. That's going to give us 12. Then I'll comment that first statement out, and then run it again, and we'll get 12 again. So you can see operator precedence still takes effect even when we overload those operators. Of course, if that was reversed, if we had something like that, it'll be a completely different answer. Okay, that's entity 1 plus entity 2, so the member is going to be 6 in that case, multiplied by 3 gives you 18. So as you can see, this is very handy because we can still use brackets to enforce what operations we want to have happen first. And here we are not using a bunch of parentheses as we do here to call various functions. Because of operator precedence, this will work right out of the box. Okay, so we don't have to do this to get the same result that we would get from this line up here. Okay, so that's going to wrap up this video. I'll see you next time.